back again. We're almost there, guys. Just hang on, okay? So this is your two-way chi-square, right? We talked about the one-way already, where we only classified people in one way. Obviously, that's very simple, and often that's not the case. And so we have a two-way chi-square, which can expand to any number of categories, but we're going to stick with the simplest example, right? And really just do people in two ways. Okay? So, two-way chi-square, the formula is the same, right? The thing is, we're just going to classify people in more than one way. And you're going to see this, right? However, when we do this, the big change here is how we compute the expected values. So the expected values, it takes more work than just dividing the categories, right? We're going to do a little bit more work to get the expected values for the two-way chi-square. I'll show you that right now. So we added a dimension to our previous one-way chi-square, now looking at two groups instead of one, nearsighted and non-nearsighted people. When they self-selected the category they belonged in, we expanded the number of subjects and we added some people and see where they went. All right. So the categories were still darkness, night light, room lights, and then nearsighted or not nearsighted. Here's what our table looks like, right? So, right, Saint, there's no argument. We said our previous sample were all nearsighted. I guess I could have reversed that. However, it doesn't matter, right? So here's what I mean. So we categorize them in more than in two ways, nearsighted or not nearsighted. It's not these categories that changed, but here. What changes is the tables, is the totals. We have these total columns and these total rows, row totals and column totals, right? Row totals, 137, 342, and then the total. And this is what we call the grand total. Okay? And that's going to become clear why we need that very quickly. So, we already have our observed values, right? These are still our observed values, the 18, 78, 41, 154, 154, 34. Those are the self-selected, where they went, and these are our observed values. Now, the work comes for our expected values. So we have basically 6 different categories, right? We have 3 categories for nearsighted and 3 categories for not nearsighted. So I broke this down, and I just identified them with these. Instead of having to write this out all the time, I just identify them with this. So that's your little key. Okay. So, as I said, the expected values is a little bit different here, right? And so what we do to get the expected value is the row total times the column total divided by the grand total. So for the nearsighted people that sleep in darkness, right, that is the row total times the column total divided by the grand total. So 137 times 172 divided by 479, and that's what I did here, right? And so then I got this, and this is, so now this is the expected value for nearsighted people that sleep in the dark. And I did that over and over. So as you see, the row total stays the same, and the grand total stays the same, and what changes at this point is the column total. Right, that's the only thing that changes. The row total stays the same. These change, and this doesn't change. So we went through this again. 137 times the 232, the column total, right? And it doesn't change until I get to that next category, that other classification of the non-nearsighted, right? So then my row total changed to 342. And now I have the same thing, right? I use 342 throughout, and I just change the column totals, and it matches that order again. So I got all of these, and these are all my expected values. Now, no, we're only halfway done, right? Because now we still have to do all of this work, right? And so here we go. And what we're going to do, right? So I have the observed value, 18 for the nearsighted people in the dark, right? And their expected value was 49.194. And so here I subtract the 49.194, I get negative 31.194 divided by the grand total, the expected values, divided by the expected values. See, I have to keep it straight too. So, right, so you square this, it's 973 divided by the expected value, and here is my, I don't even know what to call it at this point. I do the same thing repeatedly, right? Just like we always did, once for each category. So 6 times I had to do the same thing, the expected value minus the observed value, right? Because the observed value minus the expected value. And those expected values change for every category. So that's where you have to switch. Same thing, I did this, did the subtraction, did the square, did the division, came up with this. Same thing, here's my observed value minus my expected value, right? My observed value minus my expected value, right? And I came up with this, I squared it, again, I did the division, and here we go. So now I did that for every category, and now I have all of this, and now I have to sum it. And I have to get the sum of all of that. I did this for each category 6 times. I have to add those up. So I add all this up, and I come up with 55.52. I don't know what that M is for, but I can't fix it now. So 55.52 is now my observed value of x squared, right? So we talked about this. We changed the definition of observed value now. So same thing. I want to know if this is critically significant. I want to know whether I reject or not reject the null hypothesis, right? And so I need to know the degree of freedom because we're going to go back to the table. So for the 2hi squared, the degree of freedom is the number of rows minus 1 times the number of columns minus 1. Now, in this case, we do not include the totals, right? We're only talking about these right here. So I have 2 rows and 3 columns, okay? So total number of rows, 2 minus 1. And the total number of columns was 3. So 3 minus 1 is 1 times 2, which is 2, right? I look at the table, turns out it's the same degree of freedom in this case, so the critical value is the same of 5.991. Obviously, 55.52 is greater than 991. We have statistical significance and we reject null hypothesis. Okay? That is 2hi squared. A little bit more work, but same thing, not really challenging, just basic math, right? And you figure it all out. And again, as always, I am available. If you needed some help, please reach out to me. All right, thanks. One more piece and we're done. One more piece, your last piece for the entire class. We're done, okay?